Welcome everyone, good morning, to the second information security lecture about networks. Today we are going to talk about a topic that affects all of you on a daily basis. It's, after talking about security on different network layers, what we did last time, we're today heading to something you're using right now, the browser, the tool you're using on a daily basis to have a look at websites, and in that context it's also the duty of the browser to protect what you're seeing, to make sure nobody can break out of the browser, store something on your computer. So how this browser security model works, this is something I want to show you today, and also the most important attack vectors and security features in browsers. Among the most important features in terms of security a browser actually has is the same origin policy. It's a mechanism to make sure that only specific resources can be loaded from websites, and to make sure that no, let's say, attacker could inject something and send exfiltrate, for example, cookies or other secrets from you. So since this is such an important feature, we'll have a look at it, and also about bypassing it. And intuitively, this might sound quite weird. So on the one hand, you have a security feature, on the other hand, you immediately want to bypass it. But in fact, there are certain reasons why you would want to do this. So it's also important to have these mechanisms to bypass it in a benevolent way. So you can bypass the same origin policy for certain reasons. For instance, if you run an API. On the other hand, it should be in effect in case there is a need for it. So to make this clearer, we will have a look at the different mechanisms, the same origin policy, and then the mechanism on how to bypass it. In the second part of today's lecture, we will have a look at different variants you can use as a web developer in order to manage sessions. And sessions are essentially the secrets on, basically, if you log in somewhere, your session can be, for instance, stored in a cookie. But this is just one option of many. And so since if you log in somewhere and you have a session, this is like your secret, and this is what you have in order to, like what is identifying you to the website. So the secrecy and protecting these sessions is important. Of course, there are always attackers who want to try to steal something what is secret. And among the most two common attacks that affect clients is session stealing or cross-site scripting, and as a second attack vector, cross-site request forgery. So after today's lecture, you will be familiar with cross-site scripting and cross-site request forgery, and also know about different options on how to manage sessions and how to protect them, and what's important there. Probably a quick review before we start. Because this now affects the application layer and essentially everything you see in your browser, what your browser loads, so in other words, HTTP requests, responses. What happens with HTTP? How does it work? You've heard about this last year already in Con. So HTTP is a simple protocol. It just works on a request-response basis. Usually the client just opens a TCP connection. So Firefox, Chrome, they just use the regular sockets provided by the operating system and send out a request like, get me this document. They specify an HTTP version, probably some headers in addition, like a user agent, the host they want to contact, the language they understand, whether to encode or compress the transmission. And then the server responds with a document. The browser will then process or render it. So for example, if this is an HTML website, the browser will just show it, will render it. If it's a JavaScript, it probably collects it and waits until some function is called. And modern browsers even optimize what they get, so there's a just-in-time compiler in there, and this is highly advanced meanwhile. So with HTTP, there is also multiple versions. What we are now using on a daily basis is mostly HTTP 1.1 or 2.0. There's already HTTP 3 in development, which should work even faster, so it's tailored to optimize performance. And on top of all that, there are still some web technologies. So web technologies like Ajax or Ajax with long polling, where you don't repeat a request all over in a predefined interval, but you actually wait for the server to respond. And of course WebSockets, which bridge the gap between polling for information to a bidirectional communication. This is WebSockets. But this is network foundations, I'd say. You've already heard about that. We won't dive into detail here. But when speaking about security aspects, we'll need to have a look at all these techniques, because they can also be malvertised for attacks. In other words, for instance, an attacker could inject something into a website, trigger an Ajax request, and let himself send something. What this means in detail, you will hear about in a minute or so. So, as already announced in the beginning, the same origin policy is among the most important security features in a browser. And the reason for that is that browsers run websites in so-called sandboxes. So whenever you open a new tab, meanwhile it's already a tab. Previously, some years ago, it was just when you open a new window, but meanwhile each new website is run inside a sandbox, and these sandboxes are separate from each other. And you already know what a sandbox is. It's essentially like a virtual machine, or a very minimal virtual machine, an isolated environment where all the file access is restricted, so it's not possible for a website, for example, to write something to your file system. It only works by predefined APIs when you actually explicitly request that. Or for example, if a website wants to access your camera or your microphone, I think all of you are familiar with these requests the browser shows you and says, do you really want to grant access to the camera? And you want to grant the website access to your camera, and then this communication only happens by predefined APIs. So how can you, let's say, these sandboxes are cool, right? They are like a virtual machine, and I think all of you are familiar with virtual machine from very big extent meanwhile, and you know that if everything is well programmed, there shouldn't be a way to break out of the virtual environment, because it's isolated and so on. So in that context, in that sense, what can go wrong if you go to a website? In the worst case, and you all know about that from your daily experience, it could be that a website, for instance, is hacked. That you visit a blog, a WordPress blog, and it features malware. And this malware could potentially try out different exploits, try to break into your system. It could try to steal cookies. It could try to load a keylogger that tries to capture everything you enter, your username, your password. It could do click checking. It could, remember back in some years ago, Facebook was still a popular platform. People were lured into clicking on videos, and when they clicked on these videos, there was click checking going on behind the scenes. So you would automatically post that video, for example, in your news feed, stuff like that. So as you can read out from that, there is a huge potential for misuse and for attackers. And the attacks I just mentioned, like click checking, stealing cookies, injecting keyloaders, and so on, to prevent such kind of attacks, this is actually the responsibility of partly of developers, but also of the browser sandboxes. So partly developer, because sometimes it's not sufficient to trust everything to rely only on the browser. And it's also, so the developer of a website knows just better on what communication should be possible and what not. And if the developer does not explicitly specify or limit this, then the browser should have some baseline to decide what is a good connection, what is not, what to block and what to allow. And this is basically decided by the same origin policy. So in other words, the same origin policy makes sure that only when you load a website, that resources are only included from specific resources from specific origins, and not from any other resource. So to make this clearer, let's have a look at this in more detail. The best definition of the same origin policies I found is actually from Wikipedia, and it just clearly states that the policy restricts how a document or script loaded from one origin can interact with a resource from another origin, critical security mechanism, and so on. So it's like an extension or an augmentation of the browser sandbox. It means it's looking up for websites where specifically you have some secrets in there, like cookies or sessions, and it tries to prevent that someone exfiltrates them. And this works by just saying, oh, cool, this is the website A, and in case, let's say, an attacker injects something, then it shouldn't be possible that the attacker actually can send out all that data. So it doesn't actually prevent that something, let's say, exploits a vulnerability in your website, injects a keylogger. But the same origin policy should prevent that the attacker could actually exfiltrate, get the data he wants to steal. So it's like you're not preventing that someone breaks into your house, but you prevent that the guy gets out with your stuff, the thief. So this means it provides a further degree of isolation. It augments the sandbox from just constraining the resources loaded in one tab in your web browser to even limiting what resources can be loaded. And the idea is that websites that are loaded can only access certain resources or parts of documents that belong to the same origin. So this is also what the name says. Same origin here means, in simple terms, we do not want that specific potentially sensitive data can be sent to other origins. So like you're on Google.com and you don't want data to be sent to YouTube.com. So no matter whether this belongs to the same company internally, but you want to actually restrict the communication going on in your browser while you're using this as a user. So imagine in an ideal world, this would mean that only websites would load. Let's say you go to Google.com and all the resources you would see on that website are only coming from Google and only from that specific domain. In practice, this is not always usable. So just think to yourself, if you go to a website, you probably check out the contacts page, then in very many cases there is probably Google Maps included. You go to a website and you see live feeds, you see Twitter included. You go to ORF.at, checking the news feed, and you see they include Twitter, they include a YouTube video or something like this. So very often it happens that websites just have to integrate something from external resources. And if you think about it, this sounds somehow counterintuitive. So on the one hand, you have the same origin policy, which wants to constrain everything to the same origin. You say, okay, cool. If we only load something from a website the user actually trusts because he has explicitly called it, then it could still happen that you need something from external resources like Dropbox APIs. You want to include Facebook for some reason, some like button, or Instagram, or so on. So this means we also, in some situations, have to bypass the same origin policy. And before actually speaking about how the mechanism works and when to bypass it, or when is it good to bypass it, let's look what an origin is, because since this is a mechanism that's implemented, we also have to know what to decide what is an origin and what is good and what is bad, what to block and what to allow. So the same origin policy works by checking all the URLs that should be loaded based on the structure scheme, domain port, path, and params. So this is like what a regular URL is made up. And the browser just parses the URL and then sees, okay, we are, let's say, on example.com, your page, this website, and let's say this origin A, the website we're just on right now, tries to include something from other origins. So you're just, let's say there's an iframe or something in your website where you want to send data to, you want to load data from. Other resources you're including, like scripts, or yeah. So to see whether some resource belongs to the same origin, in other words, belongs to this very specific domain, it checks for the pattern scheme host port. So in other words, it checks what you see here in bold is basically what matches here, or what it checks for. So you see, for instance, in the first example, this the scheme, the host here, and actually the port, because HTTP usually refers to port 80, they match here. So such a request would actually be allowed. If you'd be on origin A on this website and you would actually include, let's say, this page 2 HTML in an iframe on this page HTML, it would work. It would not be blocked by the same origin policy. On the other hand, if the port would differ, so like in this example, I think you can see my mouse. In this case, it's port 81. It would differ from the regular one, like in origin A we have port 80. It would just differ, so it would be blocked by that. Or also if it's a subdomain, or if the domain does not explicitly match, like there is the www prefix missing, or you just include another subdomain, then this would also block it. And besides websites, there's also such a same origin policy for cookies. Because just imagine you're let's say you're going to Facebook, you're logging in there, and then Facebook sets a cookie in your computer. Then this cookie also refers to a certain host name or a certain origin. And essentially it's the host name of facebook.com. But probably Facebook also has an internal panel or something else like developers.facebook.com, where you have a separate login. Then it's basically the same origin policy decides on whether your browser would send the cookie you have, let's say for facebook.com, to the subdomain or to any other resource you call on Facebook service. So the same origin policy here is limits, for example, where you send cookies to or what resources you include to. So quite a powerful mechanism. And it can also be that you, for instance, have a server that hosts multiple websites and they are completely unrelated with each other. Then it's also the case that if the same server hosts unrelated sites, scripts from one site can access properties of the other only if they match with these patterns here. Only if scheme, host, port are the same, the path is ignored. But in practice, it can also be that the origin is not representative of the content, right? So what this means in practice is the same origin policy prevents some attack scenarios that are very, very obvious, and still without same origin policies, they would be possible. And to make this more visible too, let's look at some examples, some scenarios that are very actually realistic. So for example, in the first scenario, the user is tricked into visiting some website that looks very similar to the one he's, let's say a banking website, and instead of AT, the website features AL. Probably the user might just overlook this. You get the regular phishing email, which all of us are annoyed of, which requests you to update your data to your login credentials. You click on that website. Even the ad checker is lazy. So what you would do is just include the regular data from a regular banking website in the frame. So why would he do that? Because then he wouldn't have to copy the original page. It would just seem a bit more legit if it looked really exactly like the thing the user is actually used to. So if the user would then enter his credentials on that page, the attacker could just load or access these resources from a frame that's loaded there. So the attacker controlling login mybank AL would just apply a keylogger, for instance, include a JavaScript that features a keylogger and access the data in that frame. That would work if there was no same origin policy, because the same origin policy would actually see, hey, these two domains here, these two origins actually differ, and it will not be possible that the guy or the domain, the origin login mybank AL accesses the data of an iframe that's loaded, for instance, from that domain. That would just not work and would be blocked by the same origin policy. Or another example, and that probably also explains to you why it's important to log out somewhere. let's say you're logging into your bank account, and all the banks are meanwhile forced to force log out you after 15 minutes. But if you would, for instance, forget about this, you just want to check your current account balance, you'd go to your regular bank, you'd log in there, you do not log out, and while you're still logged in, you'd go to some website that the attacker just controls. Because you just got an email, it sounds not very suspicious. You would just go to that website, or probably just go to a website which is hacked, and then it might happen that this website just includes the bank website. So what would happen if there is this attacker control website and it would include the bank website in the frame? What's happened behind the scene is that your browser just automatically would send the cookie you got from your bank after logging in, would send it there. And in a world without same origin policy, the attacker on his page could just read this cookie as well and access everything in the frame. So the attacker could just do whatever he wants while you're still logged in. He could even keep your session upright and prevent that it's going to terminate. So again, you see that the same origin policy is actually responsible for splitting these two kinds of communication to make sure nobody's interfering with a domain he's not responsible for. And domain in this context is just known as origin. And origin more specifically means the scheme, the host, and the port have to match here. So based on these scenarios, you see that attacks actually work in two directions. So in the first scenario, the attacker accesses from outside to the inside. So the attacker controls this login MyBank AL and accesses something that's included inside, like in a frame. And in the second example, it works from the inside to the outside. So the user is first logged in, and then the attacker actually tries to access this again. And so even if you will still hear about that today, but if you already know from Con, there are certain security mechanisms you can set with cookies, for example, like HTTP only, to make sure that the cookie is only sent with HTTPS communication. Even if you would activate such security settings, the second scenario would just succeed, and the attacker could do whatever he wants by including this website if there was no same origin policy in your browser. So more visually, how this would look like is exactly as what you can see on the screenshot. So if the same origin policy is activated, let's say it's just the second example I've just mentioned. So on the left you see a screenshot that shows you that on attacker.com the attacker has included a frame that would try to load the bank.com website. And the attacker would just, so this is the bank.com, you see it here. The user is probably logged in his banking account, and attacker.com is a website that's controlled by the attacker. He would just try to include this bank.com within a frame, which is why in the browser console here it says top frame. And if the attacker would try to access this window, this frame that's loaded here, while the same origin policy is active, the browser would just say security error, block the frame with origin attacker.com because it's a cross origin frame. So this means it doesn't belong to the same origin, and he would block it. You see, of course, this example is made up, but this is probably one of the most stupidest way how you can design a website if bank.com would actually include some username and auth key and store it in JavaScript. So probably that's a very dumb way, what you usually do not do, but it serves for the example. So if the attacker would actually try to read this, to access this auth key variable here, or even the username, makes no difference, this would work if there was no same origin policy. On the other hand, if there is a same origin policy, exactly such an access is blocked, and this doesn't work. So thanks to the same origin policy, the attacker would not be able to read out if something is loaded in such a frame. And it might even look like, for example, you have your domain login bank AT, and the attacker would just forge this and change a tiny bit of the URL, and then include the bank website at 100%, so include a frame of 100% height, 100% width. The user might not even get suspicious. So this is why the same origin policy is so important. But as already said, it doesn't block everything. So everything it blocks has to correspond to this URL scheme. In addition to that, there are certain requests that always work, even if the origin is different. So, you know that I already told you that it can prevent certain attacks, and these attacks can happen very frequently, very easily. So the scenarios I've just mentioned there, not so artificially, they can actually happen in practice. But as I said in the beginning, if we reply to all external resources, if we would constrain our communication only to one origin, modern websites just wouldn't work, because they include resources from other websites very frequently. So for that reason, the same origin policy doesn't affect loading all the resources. So some resources or types of resources you can load are just exempt. So the same origin policy does not apply to them. And in this example, what you see here with login bank EL, where requests are made to some other origin.net, for example, the user loads this in a browser tab, and then it happens, for instance, that this website needs some JavaScript, like jQuery, wants to include Google Maps or something from any other origin. And if the website would then use the script tag, the regular JavaScript script tag, then this communication will always work, even if the origin is different. So this is what the green arrow here means. The same with images. So it's unproblematic to include images from other domains. And probably you might think, hey, wait, there are even iframes. Didn't it just say that iframes are blocked? Well, iframes by themselves are not blocked. So if the attacker here can actually load bank. You can include bank in an iframe, but thanks to the same origin policy, you cannot access data within the iframe. So you can just load it, but you cannot do anything beyond that. However, what the same origin policy always applies to are HX requests. So HX request is something most of you will already be familiar with. It's, for example, if there's a live ticker on der Standard.at or OF.at or something like this, then only parts of the websites are renewed, and therefore the website sends a request to the server and says, give me only this part, and then some JavaScript will render this and show it on the website basically within the browser, prepare it, process it by JavaScript, and then show the result. So HX prevents that you have to reload the entire page, but you can refresh only parts of it. What also is blocked are access to other windows. So if you have multiple browser tabs open in your browser, it would actually be possible to send something to another tab and load it from there. And this is also something that's always blocked by the same origin policy if the origin does not match, if it doesn't correspond to the scheme host port scheme, so this structure. And if you now think about this, at first it may sound counterintuitive. So first I told you it's blocking everything that's not belonging to the same origin. And now what I'm showing you is, hey, apparently a lot of things are exempt, right? So 3 of 5 things here are not blocked by the same origin policy. So you might think, oh, what sense does it make them? Well, forbidden are only those things which are critical. And this is like a compromise, because browser vendors, more basically Mozilla and Google, they have realized modern websites need resources from other origins. So they said, okay, the same origin policy is an important mechanism to block these attack scenarios I've just shown you and beyond them, but they're only blocking requests that are sensitive, like you're including an iframe, you're trying to load something from another window, access the data there, then the same origin policy would block it. It will also block, for instance, HX requests to other domains. And you will still hear today why this is crucial. This actually prevents cross-site scripting. But essentially, for example, it prevents that attackers could read your cookies and send it to some other origins. So it does its job pretty well, but to actually fit the needs, to match the needs of modern websites, certain resource calls are just exempt. So the same origin policy does not apply to everything here. So you can load images from other domains, you can load scripts from other domains, you can even load websites, but due to the same origin policy, you cannot access their data. So this is something you should remember, because a lot of people get this wrong. They think same origin policy blocks everything which does not belong to the same origin. Well, that's true, but you still have to look what it applies specifically. So it's just a mechanism that's not wrapped within, so it doesn't apply to all the resources in the sandbox, but just to some that are deemed to be sensitive, like direct access to the document object model, cookies, windows from other origins, making requests to other origins. So this should prevent attackers from exfiltrating potentially sensitive data. But if, let's say, you run a website and you include an image from another origin, from, I don't know, you have a website and you include an image from any other domain, no matter what, then there is most likely no security component attached to that. So it's most likely harmless in regular situations. What does it mean? It also means that exactly what we all hate, that we're getting tracked while surfing on websites, for instance by Google Analytics. This works, and this is not blocked by the same origin policy. So in this screenshot you see, for example, the old IRK website, and back there we had a script included to analyze how many people use it. And if you load just such a JavaScript from any other origin, like only with this line you see here on top, which is basically what every second or probably most websites do to include resources from other origins, the same origin policy would not apply to that. So if you're running a website and you include like jQuery or so from the official jQuery server, jQuery is a JavaScript framework, just in case you didn't know, the same origin policy would not apply to that. Why is this still problematic if you do that? So of course, in that example with Google Analytics, because Google will see what websites you have used and can actually track you. But it also means that, so Google Analytics is on a lot of websites, so you can actually track people where they are. But it also means, not specifically to Google Analytics, but in general, if you include on a website JavaScript from external origins, it means that potentially these origins might change. So what happens if this Google Analytics Analytics.js is hacked? If an attacker can actually hack the server, change the JavaScript, and then this JavaScript, this potentially malicious JavaScript, will just be loaded on all the websites that load this script here. So be careful from what origins you actually load scripts, even if they are not blocked by the same origin policy. Because in this case, again, you see the trade-off, what scripts to include on the website here. On a legit basis, this decides the developer. So this doesn't, what you see here, what was included in the IRK website, this is on purpose. This was just decided by us. So we knew, okay, this is a legit request, we would want to include this. And we also knew that this won't be blocked by the same origin policy. And technically this works because browser vendors think that this is no sensitive request and they just won't block it because it's no direct access to the DOM, it's no direct access to cookies. So Google Analytics could, if we had a login area here and this login area would set a cookie, then it would just still be possible to use that cookie on a page, but Google Analytics could not access the cookie because the same origin policy would block it. So just think back about the examples, the scenarios I've just shown you. So exactly these critical accesses, to prevent this is the job of the same origin policy. All right, so sometimes we have to bypass it. And in this case with Google Analytics, there is, well, no reason to bypass it because it's blocked the first way. But what if you, for example, have an API on a different origin and you still want your websites to access it. We know that we can still load resources like image tags, iframes that belong to other origins, right? This is something I just told you. But what if there's a live ticker we want to refresh, and this live ticker is just on a different origin, and this would be blocked, or a login website, the login system is in another origin, a subdomain for example. The same origin policy would block this. Or for example, Online TU Graz.at wants to include the login from SSO TU Graz.at. The same origin policy would just block it. Because what happens if you enter your login data to Online TU Graz.at, essentially you're getting referred to SSO TU Graz.at, and then this subdomain informs the other subdomain that you're successfully logged in. So to allow this communication, what's going on there, the same origin policy has to be bypassed, but benevolently, in a good way, because there is no malicious purpose behind that. It's actually, there might be reasons why you would want to do this, like having a login service on a different subdomain. As already mentioned, it can also be that you have a website like xy.com, and it's just a front end for some API. It's just using an API that's on a subdomain, like api.xy.com. In that case, you would also want to bypass it. Or another practical example, Facebook has a messenger. Since this messenger or chat is very resource intensive, they're running it on a different server and also on another subdomain. And to actually enable this, because you're logging in, let's say, to facebook.com, and then the chat is in a subdomain, it still somehow needs to get the information that you're logged in and who you are. So to transfer this information from the regular Facebook domain to the chat subdomain of Facebook, you have to bypass the same origin policy, because this is exactly what the same origin policy would prevent here. That you're sending something, let's say, in a frame to a subdomain, or getting it out from there, like the information that you have new messages or so. So how can we bypass this? Actually, so I know this sounds very counterintuitive. On the one hand, just in the first place, I tell you, hey, we have a security mechanism, it's important. On the other hand, there are mechanisms to bypass it. Yes. And what's crucial about this, and why you should be familiar with these techniques, not only knowing about the same origin policy, but also bypassing it, is because an attacker can also apply the same things to bypass it. So today you learn about the attacks, and this basically bypassing means attacking at the same time, because it happen benevolently or also by attackers, which we'll see by an example just in a few minutes. So there are 4 methods to bypass the same origin policy, and if it's done by developers, it happens in a good way, so benevolently. The first thing is HX proxy, then is JSON-P, JSON with padding, CORS, and the content security policy. The HX proxy is something that runs on the server. It's usually a PHP script or so, and if you think of a regular browser tab that's loading a website and you want to send something to an external origin, like you want to refresh a live ticker or so that's on another origin, and your browser could just not send this HX request to this other origin because of the same origin policy. Then you as a website developer or website owner, you could, for example, install a Node.js or PHP script on your website that would just act as some kind of proxy. So you would make it a server which would request this resource for you from the other origin. So in that case, if we wanted to make an HX request, for example, to sameorigin.net external resource, we would just give this to our PHP script or so, like a script running on a server, and then our server, the same server where the website runs, would make the request to the other origin, send the response back to the HX proxy, and the HX proxy will give it back to the website. And in a browser, it would look like everything is happened within the same origin, and in fact it is happening in the same origin. But what would not work is if this request was made to the other origin directly from the browser, because as already said, this is exactly what would be blocked by the same origin. So if you're a website owner and you run such a script, you can actually bypass this. You play around. So in a way that it doesn't look like a cross-origin request from the browser. The second option we have is JSON-P, and it's also something we want to include from code, for example, code from other origins. And you know that the script tag of JavaScript script tag allows you to load resources from other origins, but you cannot interact with it. You cannot send something there and then get a response that's specific for your request. So it's just a generic include, like you have seen previously with Google Analytics or Google Maps, Facebook like buttons and so on. But there is no interaction possible with that domain where you load a script from. So to work with data resources from the other websites, there's a mechanism to allow this, and it's called JSON-P, or JSON with padding. If you just load a website without specifying anything addition, so like you're just specifying the script tag, you load a resource, the problem would still be that there is a name attached to that, right? So loading a script doesn't give you something in the first place. There still needs to be a name to or any function you can call in the script. Otherwise, the garbage collector of the browser would just identify it, would simply delete it, and you couldn't access it. So to work around this, there's a mechanism called JSON-P that was invented in the early 2000s by a developer from Yahoo, who found a format that's valid JavaScript. So this is why it's called JavaScript Object Notation, JSON, and with padding does not actually refer to a padding you might be used to from crypto, but it's actually a function called. So this JavaScript object notation, this object actually wrapped in a JavaScript function call. And this is why it's called padded with, or padded in a function call. And in practice, this can look like exactly the example you see in this slide. So for instance, a website includes such a script tag, as you can see here in the top, where it says domain.com uses 1234. So for example, once you load the user record from some domain, and then the response of the server would exactly be such a JSON object. If you just would load this like this, what would happen? The browser would see it, but it would understand that there's no way to access this object. Because if you include it on a website, how would you access it? There is no name, no function tag, nothing basically, well, around it. There is no name. You couldn't say, give me the return value of that website. So the garbage collector would just remove it. And you could not show, for example, this response, what you include from the website, on your website. It would load, but it would just go unnoticed. No way to interact with that. So in order to interact with that, we somehow augment this call by adding a JavaScript function that's then responsible for parsing. For example, to process this data, to this object notation, we append, well, a function name, what you see here in yellow. In my case, it's called parse response. So the response that's been loaded by the script tag here would actually look like what you see in this box here. So what happens if a website includes such a request? Well, it would look, the browser would load it and then look for whether it knows this function, parse response, from another include, for example, or from a JavaScript that's regular on a website, and then pass this, what you see here in the green brackets, a JSON object, as an argument. So in other words, it would call the function parse response and pass this as the first parameter, this JavaScript object. So in other words, instead of just loading this JSON object without any name attached to it, it would actually wrap it within a function call and gives it there as an argument. Now, is this secure? Of course not, because a script tag allows you to load anything you want, and you have no idea what the server actually replies here. So if you make use of that API, I think, oh, okay, the browser blocked my cross-origin request, and now I have to bypass it, and you decide to use this mechanism. It's your duty in this pass response, or whatever you name this function actually, to make sure that the data is valid you're getting. Because imagine that this server would be hacked, and the data would not even hacked, if it's just corrupted, and the JSON you get from there is just invalid, or you get no response at all. What would happen is, that it's your response to pass this and to realize this. Because in the worst case, if an attacker just transforms this controls domain.com, exactly the domain you're including something from, and then it could also be that you're getting some malicious code. And if you, as a website developer, as the person responsible for this pass response function, if you develop this, it could be that, and if you do not pass this adequately, but just show it, like do a document right on your website, you potentially just include malicious code on your website. So if you use this, it's your responsibility as a developer to make sure that you pass this and try to see you really got everything you requested and nothing beyond that. So in practice, what's the problem with JSONP? You don't know what you get back from a website here. It can be that there is a malicious web service trying to inject something to your website, and if you're not careful as a developer, this might take a bad end. Now, but still you would want to ask, why do I need this? If there is JSON, why do I have to load JSON object specifically like this? Well, probably there are some tasks you cannot do on your website, or you do not want to do them, and you might want to use such a service. For example, to make this more realistic, you could run a website and you'd want to include, the geolocation of the IP address that's just calling the website. So for example, in this case, I'm calling a website from TU Graz, and on, for example, ap-api.com, that's a web service that allows you to trace back where this IP address is actually physically located. And running this service is not so simple, so you cannot there's no API to find out the IP location. So what I could do as a website owner, I just rely on this service like ap-api.com. And I include exactly this snippet here you see on the top on my website, make such a JavaScript request, specify a callback. And you see, for example, here it was JSONP equals pass response. And this example is callback our callback. So usually when a web service exposes such a JSONP API, then you can specify the function name, like our callback here. That's what you can decide, because it might be different among all the websites. And the rest of the URL is usually defined by the service. So let's say the user goes to this website, visits my website. What would happen is the browser loads this JavaScript, also this one, and what it will get back is basically such a JSON object, like the one you're seeing here in this JSON response in brackets, curly brackets. And this JSON object is passed as a parameter to our callback. And my website is then responsible for passing this data, which I do not do in a very good way, but you can see here, I can, by this query, for example, I can access it. I could print the latitude, the longitude, so I can actually access this. And without this function call here, this our callback, the website would still, load the response, but it wouldn't get processed, and I couldn't show it on a website. So the output on my website will just be geolocation for that IP address, who made the query, there was that IP address here, and the coordinates. So that's how you could, for example, include data from an API on a subdomain, but you'd have to be careful on what you get back. So this JavaScript here is managed by me as a website owner. And I have to make sure that the data I get back is not malicious. You have to parse it. So like any other data you get back from some web service, you have to make sure it's not, it's legit code and exactly what you're expecting. So the result, if you do not do this, check adequately, will just be any content can be injected into the website. If I just do here, let's say document write and then JSON data, so instead of parsing, taking out specific elements here, by the way, this is also not an injection proof. This is still, there could still be some malicious data within this JSON data latitude tag here. So just saying, so you have to make sure to parse this in an adequate way to make sure nobody can inject something into a website. And the other thing is, you cannot actually control who accesses your API. So for example, let's say I do such a request to my API to ip-api.com, then the service there could not limit who actually calls their API. They can't just say, I'm only allowing requests from this or that origin, because there is no mechanism to allow this. In practice, this is a problem, because it can be that you're logged in, let's say on some subdomain like account-example.com, which sets a cookie in your browser. And then it has a JSON-P API that would expose some user information. If now the attacker would lure the user into some malicious website, it could just include such a request, like the one you see here with script type text JavaScript, which calls this API. And the browser would include the cookie of the authenticated user, and thanks to the callback, the evil.com website could even access the data it gets back from there. So that's a very realistic scenario, and this even happened in practice. For example, Mozilla previously, some years ago, did exactly this. They managed the accounts of registered user on a specific on a separate subdomain, and then their syncing service, their device syncing service, again ran on another subdomain. And so that the syncing service could include the user data, could access it. They used this JSON-P API. But the problem is they could not control who would actually access the API. So there was no way to say that the API distinguishes, oh, okay, I'm allowing accesses to from the syncing service, but not from evil.com. This just did not exist, or this does not exist with JSON-P. So that's from the point of view here is the API owner, right? So if I'm running this API, I want to make sure nobody is accessing it who I do not want to. And to control this even better, who can access my API as a server owner, there's another mechanism to control this on a more fine-grained basis. It's called cross-origin resource sharing. And the idea is to have a better error handling than JSON-P. So the website developer can use regular HTML, XML, HTTP requests, so regular AJAX requests that already existed before this CORS mechanism existed. But with CORS, you can specify more precisely what you actually want to, what HTTP requests you want to allow and which ones you want to deny. So for example, with JSON-P, if you include something like this is always a GET request. You cannot send something there. This is just a GET request, an HTTP GET request. This is the parameter you're passing the callback, but you cannot post for information there, for example. With CORS, this works because, and besides GET and POST, with CORS, you can even have put, delete, and others. So CORS is very flexible here in defining how my API can be accessed from a server's perspective. You can even send cookies to a website using CORS. And the permissions on what requests are allowed are defined by the target server. So for example, let's say I run the website example.com, and I'd like to request some resource from another origin. And as already said, in a healthy situation, a regular situation, the same origin policy would block an HX request to third-party.com because the origins would just mismatch. So this is a regular, just for comparison, on the left here in this snippet you see a regular HX request, and the only difference if this is an HX request to another origin is that you specify the full URL. In all other regards, this is the very same request. So the left request here, this is fine by the same origin policy because it goes to the same origin, and the right request here would be blocked because it would be an HX request to another origin. So how this looks like if you call this website, how it looks like from a server perspective is what the browser sends is exactly this GET. So it just is a GET request. With CORS, the server will then see, based on this host, whether it allows this. So here you see the origin. I'm calling this, and this third-party origin will just see, oh, okay, I'm not trusting example.com. Why would it trust this? Because it sees here the origin it's coming from, the request is coming from. And as a CORS API owner, if you run CORS on the server, you could specify a list of origins you would deem trusted. And so how does this make sense? For example, let's say you run SSO-TU-Graz.at as a login service, and you want to make sure that only online TU Graz.at or the Teach Center or so can use your API, TC TU Graz.at. So if you run CORS, if you use CORS for that, you could say my API, my login API, should only be accessible, should only be usable for requests that originate from online TU Graz.at or TC TU Graz.at, or whatever other domains you define here. So that's an option, for example. So you limit the API from where it can be used. However, there's something you should not do and would also work. You could specify an asterisk. In other words, you'd allow requests from all origins. This would make your API at least as insecure as JSONP, because exactly the protection that CORS would give you will no longer be there. When you get a response from the server, it will also include such a header, as you can see here, like the access control allow origin, and it will state, so third party count, this is the response it sends back. It will say, yeah, I'm allowing exactly requests from that domain. The browser will then check if the current domain matches the allowed origin. If yes, it will pass through the response or otherwise block it. So this might seem confusing. Why? Because what's specific about CORS is that the other server always gets the request. So even if this is another origin, the browser would still send it there, and the browser would just decide on this header fields on whether to show the response or not. So what happens if you're an attacker, you run this API, you run such a website and with some JavaScript and another origin. What you as an attacker could also do, you just specify an asterisk here instead of example.com, and the browser will always show the response. Baffling, right? So what this means is that CORS is somehow flawed by design, because any attacker could specify an asterisk here and thereby bypass the same origin policy. Mind-blowing, isn't it? And this can lead to very practical examples and attacks, which I want to show you now. But before that, there was a question in YouTube chat. Couldn't an attacker just put an allowed domain in the header of the malicious request? Yes, you're right, but of course the browser will check where the request originated from. So if you just say, if it does, it's not pattern matching. So it is pattern matching, but the browser will see, okay, the request originated from example.com. So in the response, in the allow origin, I also want to see example.com. Or if I'm an attacker, of course I can make my life even easier by just placing an asterisk here. And then any request would be allowed by the browser. I know this sounds very dumb, but this is really the way Course works. So as an attacker, you can easily bypass it because you'd allowed requests from any response. You could, so even this request here on the right, which would the cross origin HX request, would actually work if the attacker would specify an asterisk here. So what does it show us before we come to a real attack example? The same origin policy is actually flawed, because an attacker can easily bypass it by even specifying such a cross-origin HX request, and then in the response sending something like this: access control allow origin asterisk. The browser would actually show the response, and thereby the attacker would just bypass the same origin policy. I know this sounds creepy now, because first I told you the same origin policy is a very important protection mechanism, and right now I'm telling you how easy it is to bypass it. But this is how it is in practice. This is nothing I have invented, this is really how it is in practice. Apparently a lot of attackers seem not to be aware of that, but this is no secret. So it just shows real life circumstances. This is with what we're dealing in the real world. So why is it bad if you run an API and you specify an asterisk here? So again, yeah, this is while I just told you, okay, the asterisk is evil from an attacker perspective, please don't forget that a lot of people run APIs and they want to protect their APIs and who can actually access them. So in that case, if you run an API, like for instance for logins, make sure to limit who can access your API, and don't put an asterisk here. It just shows the example I just mentioned that an attacker can also place an asterisk here. This is if a website loads something from thirdparty.com, and then the other side, the attacker side, for example, would just specify an asterisk here. Then this could be loaded from any other origin. But say, for example, you're a web developer, you want to protect who can actually access your API, then it's important to limit this. And only then the same origin policy will work or will be bypassed benevolently. If you do it the wrong way, like Walmart did in the US, it will be like exactly this here. So, for example, I go to walmart.com, I log in there. Probably Walmart has even stored your credit card data. And what's happening under the hood here, and you don't see it, is that they actually store this, or they include this resource from another subdomain, from another origin. And therefore, what you see here, this website here, the data here, is loaded while you go to walmart.com. It's coming from some API on another origin. Unfortunately, if you do not protect this well, it can also be that an attacker makes himself a script, and localhost is just an example here, which tries to exfiltrate this data. So what happened here under the scene, underneath? Basically, the attacker, or the user here in this case, this was for demo purposes, just made a request to this very specific API, Walmart protected with an asterisk. The API happily handed out this data. Why? Because it was protected just by an asterisk. So anyone could call it. To make this protection of APIs even more fine-grained, Core supports various headers. So you can say, I'm allowing GET requests to my API, I'm allowing POST requests, I allow that cookies are sent, or I do not allow cookies. I allow, for example, how long information can be cached and so on. So quite some headers. The headers I just summarized here, this is just the most popular ones. If you want to play around, there's a link I also pasted on the slides. It will lead you to testcourse.org. And this is where you can play around with this to get a better idea of how CORS works. So what is here is this website I linked, as I already said. This is if you click on this, try it out yourself. On the right here I have the browser console of Chrome. And it will just simulate a client and server communication. So in the regular setting, assuming, so the idea is, of course, I'm here on client CORSAPI.appspot.com, and my server is on another subdomain. What happens if I send an AJAX request if there is no CORS? Well, I'm sending such an AJAX request with XML HTTP request. It opens the connection. Here, yeah, if I'm using Internet Explorer, of course I'm not. It sends a request on load, so if the call succeeded, it will do something. In my case, it will do nothing. So it will make an AJAX request to server CORSAPI.appspot.com. So in other words, the origin will just differ. What will happen in a healthy browser? My browser will see access to that from another origin has been blocked by the CORS policy. Why? Because it didn't find any valid header that would allow such a request. If I enable CORS on the server side, suddenly the request works. So enabling CORS on the server side means the server specifies this header field here and mentions the domain it allows requests from. And this gives you, so really if you look through here, the requests, you see it also here. Where was it? That's the request header. Yeah, that's the red one here is the response from the server that's been blocked, because it included, the response here included no CORS header. In the second case, when I enabled CORS on the server side, it included this header here, which told my browser, okay, I will show the response of that server. So CORS is weird in a way, because as you can see, it always sends the request. The request is not blocked, because why? Because the client cannot know in advance whether the server supports CORS. It will just identify this based on whether there's a CORS header included in the response. And with this tool you can play around, you can even, I don't know, specify other responses. And keep credentials, for example, would define whether the server would allow, if for instance this client would send some credentials as a cookie, it would tell the servers on whether to allow this and whether to accept this. Yeah, it's red because the status code is 404 not found, exactly what I specified here. So play around with this to get a feeling about CORS. And I know at first this sounds confusing or even weird that you say, okay, there's a security protection mechanism and it's so easy to bypass it. So for an attacker just has to specify an asterisk here. Or, yeah, in my case I cannot change the origin. But if or do I? No, I cannot do it here. If you run this server here, in your case, and you want to allow these kind of requests, this AJAX requests from any other origin made, not only from CORS API, but any other domain, you would just specify an asterisk here. That's what an attacker would do. If you're running an API like Walmart, you should make sure that only, for example, Walmart.com can access and request to API, not anyone else. Because exactly in that case, what in the video you've seen, this attack worked. That another site got access to the blind card data because the browser just rendered it in response. It was not blocked by the browser, so this access was just possible. The last variant is the content security policy, and it's also the most powerful one, because the content security policy does not only allow to control very fine-grained the same origin policy, but also allows other things about your website on what to include, what to block. And this includes, for example, images, scripts, CSS, style sheets, and so on from other origins or even from the same origin. With the content security policy, you can specify on whether to allow that or not. So the CSP even goes beyond the content security, beyond the same origin policy, because what I told you just some slides ago is that the same origin policy would never look at images, it would never look at style sheet, because they are not deemed security relevant. But with the content security policy, you can even control where images are loaded from on your website. And it also means that you, as a website owner, you would define such a policy and say, well, I'm never including images from any other origins, so let's just prevent this by default. So if an attacker would actually inject something and then try to load something from another origin, it would just get blocked. So what does it mean in practice? It means, as a website developer, you can somehow fine-tune the sandbox of the browser and specify more explicitly what to allow and what to block. Why? Because the sandbox of the browser is good, but it's designed in a way to work with all websites. It doesn't know beforehand where resources should be included from, and cannot only always say, is this a good request or is this a bad request? So with the CSP, you can fine-tune this and tell the browser to enforce a specific policy you define as website owner. And therefore, certain tags have to be distinguished. So if you, as a website owner, you apply the content security policy, you will include such a header, such an HTTP header in your response to the browser. And it will say, for example, by default, the default source for any script, style sheets, and so on, for example, is by default, I don't allow any resource to be included at all. But then, for example, scripts only from the same origin, images only from the same origin, style or sheets also only from the same origin. Of course, the policy you see here is very strict. But there are different tools to find a policy that will match your needs, and that all the tags you can limit here, they have to be supported by the browser. So for example, in my case here, my Chrome is modern, and I guess most of you will have modern browsers. You can steer very precisely on what to block and what not. But this is not supported by all the browsers. So more modern browsers support more rules here and more fine-grained policies. As already said, the idea is you have to sandbox your web application in your browser, but you create another one, or you extend the existing one in your browser by more specifically allowing what to load from there. That's cool. So for example, you can forbid mixed source request. You can, for example, forbid that your website calls HTTP if it's HTTPS. It can restrict cross-origin AJAX. So exactly what we allowed here was always possible. We couldn't prevent that our website does such a request, except if we're using the content security policy. We could specifically include an HTTP header that would say, no, such a request will not be allowed. And if the browser will then see such a request, it will just already block it before it even goes out. So even before the response is made, the request is made, it will be blocked by the browser. It can also prevent, for example, that certain dangerous JavaScript functions are called, like the eval function to evaluate a certain statement as JavaScript. String is a JavaScript basically. So you can actually, as I already said, fine-tune or make a more strict policy that can even prevent some attacks like cross-site scripting. In other words, injected code will not be that powerful because as a website owner you will have already limited it. And to remember how it works, probably think of the permissions you know from Android and iOS, where you allow a certain app to do certain things and prevent others. Like the app requests you to access the camera, you would say, no, I do not allow this. So to some extent comparable. And as I said, these, depending on if you have modern browsers, a lot of these rules can be set and can be enforced by the browsers. So for example, if you only want to load resources from the local origin and another one, you'd define a default source self. So self means same origin, and probably eventually specify an additional origin. Or you'd say, I'd only like resources from HTTPS origins, then you'd specify HTTPS here. And you can also block it, you can say, or mix it. You can also say, for example, by default nothing, you blacklist everything, and then you whitelist specific things by saying scripts can be included from the same origin, style sheets also, and in case there is an HTTP request, I'd like to upgrade it to an HTTPS request. I'd like to block reflected cross-site scripting, and so on. So very specific rules here, which you would have to define as a website owner. So this is not something that's there by default. You really, if you run a website and you're very careful about security and what is loaded from where, what are resources, then you would have to specify explicitly such a content security policy. And it's powerful because it's actually strengthening the sandbox of the browser. It's telling the browser what to allow and what not. But the problem is it can be a bit mind-puzzling for developers, and sometimes people are afraid of using this because when some request is blocked, they don't always immediately understand why. I'm pretty sure this won't be a problem for you. And in addition, to simplify it, there are some tools like CSP is awesome, which help you in creating a content security policy. You could, for instance, say, I need, for example, I want to include Google Maps on my website, so I need an access to the Google server. So as a host here, you would just specify the Google server, for example, by I'm allowing scripts from local origin, and in addition this host here. So what it gives you back is a header I could include. So for example, this would mean by default don't allow any inclusion from anywhere except for scripts from the same origin and from that origin. So in other words, it helps you, if you run a website, to make sure that everything is only loaded from where you expect it and nothing beyond. And even if you, let's say you run a forum and people, you don't want users to include images from any other origin. They might be, I don't know, just don't fit your expectations. You could define the same origin policy that would constrain all the images loaded only to the local website. So we just say, for example, only from the same scheme host port. So see, they actually fulfill the same origin policy. Then there would be a self statement here. Okay, that was default. Gotta do it with image, yeah. So images would then be loaded from the same origin only, and if you include when a website try to include an image or a script or so from any other origin, it will be blocked. Probably even if it's not malicious. But this gives you a tool as a website owner to enforce a very precise policy on your website to make sure that only resources are loaded from where you expect and where you want them from. So where does the same origin policy still help, and how to defend certain attacks? Because I told you how to bypass it, but it still fulfills certain purposes, and it's important to understand when to bypass it, or when it's a bypass and in a good way. So for example, a scenario you might encounter probably not only once in your career is you run an API on a server, and you want to protect or make sure that only the legitimate website can access it, but it cannot be called from an attacker's page. Second scenario I'd like to look at is how can you protect your web application from injected code. Also something that can happen quite easily. So just imagine, hopefully you won't do this on your own, it's quite a tedious job, but let's say you program a forum or some guest book or whatever, where users can enter something, a block system where people can comment. You want the inputs to be secure, and you don't want anyone to be able to inject something. So you want to, of course, first remove the possibility that someone injects something. But if this is no option, you want to make sure that the impact of this injection is not really high. So you want to make sure that we constrain the effect of this. So how can you prevent this? For example, you get a phishing mail in the first scenario, or Preisjäger.at or something you see, oh, please go to that website, you get free beer. You appreciate the offer, you go there, and there will be a call to another so the website you go to is loaded in this browser tab E. This is evil.com, and it will try to make a request to some API.net. So probably logged in there. This is Facebook.com or some banking API. Usually you're logged into Facebook or Instagram for a long time, also Google. So if this evil.com would be able to make an AJAX request to that website, you could exfiltrate your data. So how do we block this? It won't work by an AJAX proxy, because evil.com might easily set up this himself. JSONP won't be a cure either, because I can easily, if I run such an API and it allows JSONP requests to feature such a JSONP API, I just specify as an evil.com such a callback here, call the API, and then pass the response. So there's also nothing I could block here. But I could use, if I'm running this API, some API.net, if I'm the owner of that API and I want to prevent that someone calls it, like evil.com, I just use CORS for that. And thereby, as you've seen in the example before, you'd say with some API, this API should only be called the allowed origin header, would only be, for example, my social network, my banking website, but not evil.com. Second example, you want to protect against code that's injected, for example, a keylogger or so. Our goal is, remember again, an attacker should not be able to inject something into a website, or even if he is possible to do so, then we don't want this code to have an effect in practice. So an AJAX proxy does not prevent this, or doesn't help here, because unless you filter for the information that's been loaded, an attacker could easily use such an AJAX proxy himself. With JSONP, you specify a callback. So with JSONP, there is a huge possibility for injections, as already said. So it's your duty, if you run your site, this site, your site net, if you run JSONP, it's your duty to filter this code. But from an attacker, by design, it's quite easy to inject something. With CORS, the header is only set at the target. And as I've shown you, if evil.com would run an API and specify this allowed origin asterisk, the response would of course been shown. That's the problem I showed you previously with CORS from an attacker perspective. An attacker can easily bypass the same origin policy by setting the asterisk as the allowed origin header. So the last option we have here to prevent our website from this injection is to specify a content security policy header. Why? Because the CSP allows you to specifically say from what origins we want to load code from. So probably we only want to load resources from your sitenet, but we do not want to load them from evil.com. And by specifying a content security policy, the browser, our sandbox in the browser, would be aware of that and would not load or do the AJAX requests on evil.com, even if evil.com tries to bypass the same origin policy by setting, for example, by sending a CORS header with the asterisk. So the CSP will still block it. So summarizing, this is of course like a recommendation if you're developing such a web application. I think many of you, or a lot of you, will have done so already, or probably been in that situation once. Be cautious when you include script elements that point to third-party sites, because eventually these sites might get hacked. And you for sure have seen many sites that include something from other origins like Twitter feeds, the Google Maps API you find on almost every contact website, live tickers, and so on. So if attackers gain access to these sites, they can just malvertise them, and wherever this script is then included from will also run it. Then the second thing is JSONP is not secured by design. Why? Because you include scripts from other origins using the script elements, and you have to, you don't know what response you get back there. So you have to filter it and make sure before you show anything to a user on your website that this is a legitimate data. The other thing is, when using CORS, do not set the asterisk as the allowed origin, because this somehow thwarts the whole security of what you actually want to achieve when you protect your API. Because, so for an attacker, as if I'd be an attacker, I'd for sure set the asterisk, because thereby the browser would for sure render the response I'm sending as an attacker. But if you run an API and you want to control who can access it, then you must not set the asterisk, or you're doomed, because someone can just send you a request and your API will happily reply. And the browser will render the response. So that's the first part for today. In the second part, we will have a look at more on what secrets attackers are actually interested in on websites and in your web browser. Because, well, in protecting from code injection is one thing, but it's always about code injection. Sometimes it's also about stealing secrets. And remember, in the very beginning, I've told you that HTTP is stateless. So that means any request is considered unrelated to previous ones. The server doesn't have session information. You can, in other words, you can stay as long as you want on a website, but there is no, well, it doesn't always go this way that you at first log into a website, you stay there, then you log out. Usually, like with Instagram or Facebook, you log in there once a month, probably, even if even once a month, and then you stay there logged in for a very long time. Or Amazon, for example. So the server there does not maintain your session information. It does not really remember if you logged in or not, but still it somehow wants to re-identify you. Of course, it cannot use your IP address for that, because you might travel around, we might have different IP addresses, so it needs something more precise. And something more precise to specifically identify you is a session ID. So a session ID is just a unique identifier that's identifying you as a person, as a user, and that's sent with every request to a certain server. And in practice, we have different options on how to manage these session IDs. So probably just before we come to these different options, let me clarify the relevance about the session ID. A session ID is probably just some identifier, but whoever has it can identify as you. So you're not always sending, if you, for example, you're using Instagram, it's not that for every request your username and your password is sent from your browser to Instagram server. The server doesn't care for that. He just wants to know that you are really that user. So in other words, it gives you a session ID as soon as you log in, and as long as the session ID is valid, you're identified as this user. So the session ID is like your secret, and whoever has the same session ID will appear as you. So it's like a token or something, like a replacement for the username and password, a substitute. And as long as the session ID is valid, it's like an ID card which you show to the website, even if you do not send any credentials like a username and password. What's the difference of a session ID to a user ID? Well, sessions are usually short-lived. They're created as soon as you log in, and usually after some preset time they expire. So for example, you're probably all familiar if you, for example, order something on Amazon, very often or usually you have to re-authenticate, you re-log in if you actually, when there is the buying phase, if you the checkout phase in the shop, because then apparently the system needs another session from you. They want to assure you it's really you right now, nobody who hijacked your session, so they want to authenticate you. It can also be that your cookies in your browsers, for sure you will already have played around with the cookie settings in the browser. You can, for example, all the browsers, the modern browsers feature the ability to delete cookies when closing the window, after some time automatically, and so on. So as I've already mentioned, cookies are the most the most popular choice on where to store session IDs. But a session ID itself is nothing mystic. It's just a randomly chosen string that's hopefully randomly chosen, because it should only identify you, and it should not be possible for others to just figure out what session ID a certain user has. So in other words, impersonation should not be possible. It should not be predictable. It should not come from a weak random number generator. It should belong to a huge key space, and you get it after logging in. It should look random. It should not look as generated by according to some pattern or system behind. So when do we show this token or the session ID actually? There are 4 options, and they are not all equally secure. The first option is the website owner can actually include the session ID in the URL. So actually pass it as a parameter within the URL. Or the most popular option, probably cookies. So most cookies in your browser, which your browser manages, actually hold a session ID. In other words, you log in somewhere, and after login you get a session ID, your browser remembers it and stores it in a cookie. So the cookie is just a tiny string holding a session ID and some parameters in addition, like an expiration time, some security flag, and whenever you access the website again, your browser will just resend the cookie. Another option, probably a bit less frequently in use, is via hidden tags. So you actually don't see this, but this also happens when you, for example, post something in a forum. Then very often the session ID is cloaked there as a parameter of that form, which you're just sending. Or via tokens in the header, so-called bearer tokens, which are also an option that I want to show you because they're gaining increasing popularity. So usually these 4 mechanisms here are used mutually exclusive. So there's no technical need for that, but usually if you're a web developer and you you need a user management, you somehow have to, there is users who authenticated your website, you have to decide for one of these options. And they're not all equally secure. So probably a very risky way of encoding session IDs is by storing it in a URL. For example, let's say there's there's a website, and as soon as I log in there, I get a session ID which may resemble a SHA-1 hash. this could be a valid session ID. So this is something you actually see in practice, that a session ID can look like it's just a SHA-1 hash of whatever information. And then the website would just include it in every request. So in a setting where no cookies are allowed, or if browsers would block cookies, then this would still work. Because it would actually, a session ID would be embedded in all the websites loaded and all the resources loaded from a website. So actually managing this would be the responsibility of the web server owner. Unfortunately, why I just say it's risky, is that web servers usually log requests. And they also logging requests means they will also log such a session ID. And this would mean they could easily identify who was on what website, when. The other thing is that browsers usually have a history, they manage a history. So if you, let's say, click a link in your history and it contains such a session ID, you'd of course you'll immediately be logged in. This might be a minor issue, but it's because you're in the browser, it's your browser, and clicking that is not really so problematic. But it could also happen that for example, want to share a link with someone, and if you then copy this link that includes a session ID, then the other person you would hand over this token, the session ID, to the person you're sharing the link with. In other words, the other person would also be identified as you to the website. It would show as you to the website. And last but not least, the session ID is also exposed in the HTTP referrer header. What is the referrer header? You've already heard about this in Con last year. The referrer header is an HTTP header that's always sent if you click on a link, for example, on a website. So for example, I'm on wetter.fat, want to check the weather forecast for tomorrow, and then I click on the main page to also read the news. Then my browser would include such an HTTP header that's named referrer, and that would show the target website where I'm coming from. Now, if let's say this wetter.fat Steiermark there would be a session ID in addition, then the session ID would also be sent to a target website, and it would show up there in the log. And this does not necessarily have to be the same top-level domain. It could also be another origin. It could be, I don't know, IAKTU Graz IT, and then IAKTU Graz IT would also learn it would learn not only where you're coming from, but also the session ID that you used on that website. I mean, of course, this is an artificial example because you see no session ID here. This is just something I made up here. But if there was a session ID, because I know I manage this website, I'm logged in there, I'm probably the admin of the website, then I would share my secret session ID with the target server. And you do not want this because you're handing out a secret unintentionally, of course. So this is why I say it's risky, and whenever you can, you should not use this if you manage a website. If you own a website and you need a user management, probably bad idea to use this mechanism. Another option, hidden field, probably a bit less frequent, but it's been in the past in forums and so on, it's been very frequently used. And here, instead of the URL, the session ID is actually embedded as a form field in a form when you send something. So for example, you want to write a comment in a blog, and you're logged in for that, you're authenticated, like in this Disqus commentary function in WordPress blogs, which you can include. You could, as soon as you're logged in, there's a hidden form field with such a session ID. And again, you've seen this example, this would be a regular SHA-1 hash. It doesn't have to be SHA-1, it can be an arbitrary thingy, but it should hopefully be not easily brute forceable or guessable. So as soon as the user hits the submit button in this form, in addition to the other params, the session ID would be sent to the server. The good thing is, the positive thing is, the URL itself does not contain the session ID, so it won't get locked. It's contained as in the body, as the payload of the HTTP request. And and it's again the website owner who has to manage this. So in terms of security, this is actually not so bad. It's not visible to the user, but in case someone manages to inject something in the website, then the script could actually read this out from the DOM, from document object model. If the attacker specifically would know, hey, there is a session ID in this very specific object in my source code, then the script could access it and actually read out the session ID. So this is just something you should be aware of. Another option is cookies. Cookies is, as already said, for sure the most prevalent thingy, the most prevalent option. We have to store session IDs, and usually we distinguish between different cookie types. So most commonly there are session cookies, which have no expiration date, and they're only valid until the browser is closed. So this makes them a session cookie because they'll delete it after the session is over again. Most likely you use persistent cookies. So persistent cookies are usually when you, let's say, yeah, for sure you probably for you to more easily remember this. At many websites you are asked whether you want to stay logged in. And depending on whether you tick this checkbox to stay logged in, either there is no expiration date set in your cookie, which makes it a session cookie, or there is an expiration date set, which would then make it a persistent cookie. So in other words, it would remain stored in the browser even if you close it and reopen it. Then there are of course the hated third-party cookies, which means, for example, you call OFAT, it includes some advertisement, and this advertisement comes from another server, and while you contact the server also sets a cookie in your browser. So this would make it a third-party cookie. Third-party because you it was not the main domain you called. So it's not the first party, but the third-party cookie. And then there are also super cookies. So as I already said, cookies hold an expiration date. But in addition, they hold the host name they actually issued for. Because it can be that you have different credentials for different session IDs, for example, for Facebook.com and for developersfacebook.com. A super cookie would specify as a host name, would specify an entire top-level domain like AT. So if there's a cookie set for that domain, it would be sent, for example, for AT, it would be sent to every AT domain. And this would allow you to track users. Because you would allow it, for example, you run some page that's very frequently visited, and if such a cookie would be included in all the other pages, it doesn't even have to be AT, it could also be even wildcard, then you could track where users are going. In case you just see this cookie again, you could figure out where the user was previously. And there are also zombie cookies that are recreated after deletion. So even if you clear the cookies, they might still be recovered from another storage. So some years ago, Flash was still a thing. In January 2021, Adobe will finally eliminate Flash. But previously, for example, Flash had its own storage, and it was possible that session ID session information was stored in the Flash storage. Or what modern browsers nowadays have is a so-called HTML5 storage that allows you to store something a bit bigger than cookies. And if you run a website, you could also store a cookie there, for example, in addition in the HTML5 storage. And then if the user comes back, you just restore it, or try to restore it, try to find it in the HTML5 storage. If it's there, reload it there. So this is an option to bypass cookie deletion. Just do not only store it as a cookie, but also store the information in the HTML5 storage in addition. Thereby, even if the user then will clear the cookies, they can still be recovered from that storage. So how does a cookie look like? I think many of you have already seen this, exactly like the thingy I've here highlighted with a red line in the screenshot. You see, for example, here apparently I took part in some voting, and apparently it remembered that I have voted there. It just, I see this by the name. apparently in 2 votes even, and this prevents that I will vote there, take part in this vote again. So if I delete the cookie, then this information would just vanish. And how this looks like can actually be decided by the website itself. So you see, for example, here it says vote something hub session, Vietnam 2 session, whatever that is. This is actually something the website here, in this case OFAT, came up with. If you run a website, it's up to you what you store in there. Usually it's just some tiny text parts. It can also be a session ID, and you as a developer would just say, I don't know, for example, cookie colon session ID something equals your session ID. So the format, the structure here is up to you. But in addition to that, there's some attribute that's always set with cookies. So when is a cookie set? Usually by a server, and usually after you do something. So for example, you visit a website, you get a cookie, and the web server informs your browser about setting a cookie using the set cookie header. So for example, in this case here, my browser already had the cookie, so it's just sending it with requests. If a server wants to set a cookie, it would specify the set cookie header. If the browser sees this, it will just store the cookie and send it back then for each website that's visited. And yeah, as I already said, it's up to you as a web developer to specify what you want to store in a cookie. But other than that, it always follows a certain structure. So for example, there's always a domain you have to set in your cookie, because probably you want your cookie only to be valid for IAK, QCrowdCT, but you do not want to apply it. Do not want to send it to, if you make requests, for example, to IICM or whatever other institute or so, or to the Git server we run, then you do not want to send the cookie there. Then you would limit the domain to that, to some specific subdomain, for example, and eventually even specify the path. There might be different paths or applications you run on different paths. So you could even constrain the path where the cookie is sent. So this is what helps the browser to decide when actually to send the cookie to a server and when not. Then there's the expiration date, which means when the browser should actually eliminate the cookie. And if none of expiration date is set, it will just vanish as soon as you close the browser. And then there are 2 flags, the secure and the HTTP only flag. They are security related. If the security flag is set, so it's really a Boolean flag, which is 1 or 0, which you as the manager of the cookie, of the website owner, you have to set this explicitly. And you have to say, only allow the cookie to be used with HTTPS connections. So for example, do not allow that someone steals the cookie when in an HTTP connection. You know that man-in-the-middle attacks are by far easier if HTTP is used. This is something I told you last week. So probably we only want our cookie to be sent with HTTPS, and then we would enable the secure flag. Or basically, please always enable the secure flag. Second option, security related, is HTTP only, which means if this is enabled, then our browser would prevent that the cookie can be accessed by JavaScript. So something like alert document cookie on a website would not work if the HTTP only flag is active. It would allow only that the browser sends the cookie with regular GET requests, but not that JavaScript accesses it. And usually, in most cases, something like this, an access to document cookie, is not even necessary. So if you ever code a website and there is a user management in it and you store session IDs and cookies, please enable these 2 flags. And please keep in mind that the expiration date is not security related. This is something I see in exams all over, that people think, yeah, if I send a short expiration date, then I'm holding high the security of my cookie. So the expiration date has nothing to do with the security of your cookie. It just means how long it lives in the browser until the browser actually deletes it. But it does not prevent, for example, that someone steals it. It does not prevent that it gets sent via insecure connections. There's only these two options here, secure and HTTP only, that have some security character and that prevent certain attacks. So how does it work with cookies in practice? For example, as already said, the most common use case for that is you request a website. In my case, for example, I log in at Facebook, so I send a post request to Facebook service with my credentials. And after successful login, the server tries to set not only one cookies, but a couple of them in my browser. So try it out, open the browser console for any website you log into, for example, and you will see that after successful login, the browser will set a cookie, or in a case Facebook, multiples. I assume that my session ID was in this s equals something, so I've truncated the string a bit. And you see, for instance, there is an expiration date, also a max age. So in other words, either if the expiration date is reached or the max age of the cookie, then it will be deleted unless it's refreshed by the server. And as you can see, there is multiple cookies are set for whatever reason, for whatever purpose, I have no idea. You see that there are two of them, for example, Thursday, the 1st January of 1970. So if a server set such a date in the past, it actually instructs the browser to delete that cookie in case it's still there. So such a cookie with an expired date in the past will not be set. It just tells the browser to delete it in case it still has it. Because otherwise the browser would always accumulate new cookies but never delete them. So actually, if you're a good person, you will also tell the browser if there are cookies it should delete. And you see, for example, this cookie, this would be sent if the browser would have this, and it would not get deleted. It would send for any request to Facebook servers, so even for any subdomains, because this domain equals .facebook.com would apply to any subdomain of Facebook. And you also see that the HTTP only flag is set, so which means it wouldn't be possible for a script to actually access this cookie. On the other hand, you see they do not set the secure flag. Assuming that this s equals thingy was my session, here they did set it, so this would make sure these two flags that only the cookie is only sent with HTTPS connections and scripts cannot access it. So in case you ever program a user management in a browser web application, make sure to set these two flags, unless you have very good reasons not to do that. But as I already said, the expiration date is no security mechanism. Please remember this for the exam and beyond, of course. So assuming I'm now logged into Facebook and then I call another page, what will happen is that my browser will just resend the cookie. So this tells the server, oh, right, that person sent me a cookie, and based on that I can identify who it is. So in this case, for example, you see there are different whatever parameter. I didn't even know what it is, so I stripped a few thingies here, because back then my cookie was still alive. So for any request you send, so for example, if let's say you want to do a checkout on Amazon, you log in there, the server will then send you a new cookie. Probably its lifetime is very limited to a session or so. In other words, it has no expiration date. And then for any additional step in the checkout phase, your browser will send the cookie in the request header, and the server will interpret it. Oh, by the way, just because I see it here, see, this is exactly the example I brought beforehand. Facebook includes the chat from another server. It pulls for new messages here, and it does so by an XML HTTP request, by doing an HX request. And for this to work, they bypass the same origin policy, so they specify facebook.com as an allowed origin. So that's just a reference to what you've just heard today about CORS. This is how Facebook bypasses it in a benevolent way. And they even to that subdomain sent the cookie. And for the servers to allow this, it specifies the allow credentials true. This means cookies are allowed for that request. So they bypass it, the same origin policy, using CORS in a benevolent way by allowing cookies, sending an AJAX request to subdomain. So just in addition to sending the cookie, this is, by the way, the illustration of how they use CORS for sub bypassing in a good way, in a non-harmful way. So what's the good thing about cookies? Well, they do not appear in server logs. You cannot easily copy this to someone. And it's possible, but you have to know exactly where to look and how to do it. On the other hand, what the problem that's typically associated with cookies is of course tracking. So whenever a cookie is set in your browser and you then revisit a website, the same cookie is sent again. So you can profile how often a website was called, by who it was called, and for how long. And certain technical issues can arise, like if the traffic goes over HTTP, which fortunately gets less frequent now in recent years, the cookie could easily be sniffed. So let's say someone does man-in-the-middle attack and sees such a request where you send the cookie with your session ID, the other person could just impersonate you, use the same cookie. It's like copying a session ID to someone. So the other person could just identify as you. Two other technical possible attacks, which are very frequent by the way, cross-site scripting, or also abbreviated as XSS, where an attacker injects code into a website because it's potentially malicious, because it's vulnerable, and then tries to steal the cookie. Or cross-site request forgery, where an attacker tries to trick you or a browser into executing an action you did not actually intend on purpose. But we will still look at these two attacks in detail because they are very often occur, they happen very frequently, and you should be aware of that. So the last option of these four on how to manage session IDs are bearer tokens. They seem to be like cookies, but they are just sent in regular HTTP headers. So for example, a user authenticates using a regular username password or so. The server returned a so-called bearer token. The client saves it somewhere, not as a cookie, but for example, HTML5 local storage. And when the user then would request this, there is some script running, some JavaScript, which would get out the token from the HTML5 storage and send it as an additional HTTP header. And this is becoming more and more popular in the last years, for example, in the form of JSON web tokens, simple web tokens, or SAML assertions. The cool thing about that is you can store more, or even by far more than in cookies, and the server can even sign it. So you can make sure that, for example, a cookie is only used once, something like a cookie, the token is only used once, and then it needs to get refreshed. So this makes it easier for single sign-on scenarios like we use on the TU grants. I don't think they use bearer tokens, but it might be a good idea to do that. You don't need a third-party cookie for that. You don't need to bypass anything for that. You can pass the identity of authenticated users between, for example, two services, like some single sign-on service and the target service. The token, as I already said, contains more than cookies, not only a session ID. For example, you can store whatever you want, and this is usually identified or known as a claim. So, for example, you can make statements about a user plus additional metadata, and this is then known as a claim. And these tokens can also be signed, which is why they're usually known as JSON web tokens or JSON web signature if they have a signature. And this means, for example, by signing them as a server, you can testify that you issued them and they were not artificially crafted, nobody played around with that, and you know exactly the data that's in there. So how does it look like? For example, You log into some website, as I always said, the server returns a JSON Web Token instead of a cookie, and the browser remembers this in some HTML5 storage, for example, sends it back as an authentication header, and the server will then check what it just got, make sure, for example, the signature matches. In other words, it's really the token that's been issued by the server beforehand and not by someone else. Nobody played around with that. And only then, for example, you get a response from the server. The cool thing is you can use this to, well, not only store a session ID, but also something like first name, last name, or additional information which you do not want to be stored on the server. You probably want to have this stored on the client side, but you can use a web token just to sign it, to make sure, okay, this is something I'm aware of as a server, and nobody should ever play around with like credit card information. Probably you don't want to store credit card information on the server, but on the client side, you could use a JSON Web Token for that. So if the server would be hacked, then no credit card information could be found on the server side. So how does such a web token look like? Well, there's always a header, a payload, and a signature. The header carries two parts. It declares the type, so what type of token it is, like in this case JSON Web Token, and the hashing algorithm to use. Then there is a payload which will carry the bulk of your JSON Web Token. And this is where we'll put the information that we want to transmit and other information about our token. For example, as I already said, like first name, last name, or what would also make sense in practice is like credit card information. You probably don't want to, if I'd order something on AliExpress, I'd probably want, rather than having this on their servers, I'd like to have this in my local browser, in my storage. And then if they don't do it, of course they store it on the server side, but it would be more clever from a security perspective to not have it there. But in the browser, and just have the server issue a token which encloses this information, and for example just sign this, use a signature for that, which would testify that, okay, this is really the data that I've seen. Nobody should ever change the data, so otherwise the signature would vanish. It's also an integrity check, and all that together is base64 encoded, and then concatenated by different dots. So there's just a dot that separates the header, the payload, and the signature. If you're curious and you want to play around, then go to this website here. It allows you to craft your tokens, to see how this looks like, and how this works in practice. So last part for today, client-side attacks. And here I'd like to look at some attacks that happen very frequently, and they all intend to steal your session. As I already said, sessions are the secrets that identify you to a website. You don't always send a username and password to a website, but usually you authorize to a website, authenticate to a website using a session ID. That's most likely stored as a cookie. That's the way we use it, the mechanism we use nowadays most commonly. And whoever has a session ID can pretend to be you. So attackers found different ways on how to exfiltrate the session. And we thereby distinguish between, for example, session fixation, and attacker actually tries to give you a session ID it knows beforehand, or if it does not know this, if it cannot pre-calculate it or fix a session ID beforehand, it tries to steal it using certain mechanisms. Prediction is one of them. Can be hard if the session ID is generated weekly. Brute forcing also only works if generated weekly, or by sniffing, like doing a cross-site scripting attack. Session fixation works by the principle that a session ID is issued and will not be invalidated after another successful login. So for example, let's say there is a vulnerable shop, an attacker logs in there, it gets a session ID, and this session ID is for even in the URL. Remember back a few slides I told you this is a very risky approach, so I do not recommend it. So let's say the website returns this session ID in the URL, then the attacker would send, for example, like a product recommendation or something like this to the victim. The victim would click this link, would sign in using his session ID, and in case the server would not regenerate the session ID after login, the attacker would already know the ID. And usually this problem arises when there is some custom-made session management scripts, and actually the developer did a crappy job when coding this. So if session fixation is possible, then the developer made a mistake. This is not something that happens by, I don't know, insecure browser settings or so. So the first flaw, the first thing that went wrong probably is that there is the session ID encoded in the URL. The second thing, that the session is not regenerated if you share a link. And you might wonder, but this actually happens quite frequently because people are just not aware. So in the standard settings, if you just do a session management using PHP, there are certain functions like session start, session revalidate, and so on, but you actually have to know what they do and how to use them properly. And apparently a lot of people are not aware of that, how to do it properly. So something like session fixation is apparently possible and still works in some crappy credit card sites. So imagine this example here. The attacker signs in, gets a session ID, sends the link to the victim, like, look at this product, how this is cool. Like an offer, you should order it. The victim does so, enters the credit card information. Well, what happens next? The attacker can also see the same information, everything the user entered there, because they are both logged in at the same time. So one way to fix this would also be to say there must be only one user, one IP address logged in at the same time, for example. This would automatically, or otherwise you'd better beforehand regenerate the new session. Other option, session hijacking. So actually hijacking means stealing it. That's very easy. If you do man-in-the-middle attack, and the website uses HTTP, because then the attacker will just be able to sniff the cookie, can install it in his own browser and then pretend to be that user. So that's why HTTP is so dangerous and bad. On the other hand, there is still man-in-the-middle possible on HTTPS connections as well. And unfortunately, in very many cases, as we'll hear next time, users still proceed even if they get a certificate warning that something is fishy with the connection. They still click accept and go on. So in that case, man-in-the-middle is always a way to capture the session ID from some recording you made, like URLs or HTTP headers when cookies are sent. You can also, as an attacker, also leverage flaws in processing. So probably, as you remember what you have seen here, the screenshot from Facebook. Not all the cookies that Facebook set actually were set to HTTP only and secure. For example, there was this cookie, that cookie. They had neither secure flag nor HTTP only flag. Probably because Facebook just thought, well, why would we want to set this? This is nothing sensitive. This is just some, I don't know, status flag we need to set there. So why would you make this? Why would we set these security flags? Well, probably it's not a bad idea to set them every time, always. Because if you do not do this, and for example, attacker manages to downgrade your HTTPS connection to HTTP, and the secure flag is not set, then the attacker might just be able to read the cookie in a regular man-in-the-middle attack. Or if there is the HTTP only flag not set, then the script is accessible in the cookie, by JavaScript. And in most cases, there is no need to actually have this, so that something like this is possible. So if you want to try this out, go to an arbitrary website, call a website in whatever you want, which one, where you have probably even one where you're logged in. Then open the browser, tools, the web developer tools, and in this console here, type alert document cookie. And eventually, it will be in many cases it will be possible that you will just see the cookie, the website just set for you. I mean, it's actually easier to just go to the browser settings, which will also show you the saved cookies. This is also a way how to find cookies set per website, but this is if it will not be visible whether JavaScript can access this. So if you want to try this out, just open the browser console of an arbitrary website and insert this statement here. You will be surprised that you will, for many websites like Facebook, you will get even multiple alerts that show you cookies because Facebook sets many cookies in your browser, and even in 2020, a lot of these cookies do not have the secure flag set. The HTTP only flag set. Probably because Facebook thinks they're not important from a security perspective. And there are two attack scenarios, cross-site scripting and cross-site request forgery, that happen very often. They're very often done by attackers to steal session IDs that are stored in cookies. And essentially it works, the idea is to inject code into a website which is vulnerable somehow. So an attacker somehow manages to inject code because it's probably not filtered. You post a comment on a website, like in a blog post, and whatever you enter is not filtered. You can even insert JavaScript there. So an attacker would just insert code that will be rendered in another user browser. So if a JavaScript is rendered within the same origin of the website, it just bypasses the same origin policy. So that's obvious for whatever JavaScript runs in the same browser session. You can, of course, it will always be executed because there is no same origin policy it could ever violate. So what's the idea? An attacker could potentially steal your cookie. It may access the victim's cookie using this document cookie, just what I've shown you with the alert document cookie here. And it might contain, in the worst case, it might contain a sensitive session ID. Another option, of course, if an attacker is able to inject something, he could also inject a keylogger. And eventually, just imagine Facebook would have this, or Instagram, or whatever platform, and you as an attacker would be able to inject JavaScript that would just listen for keystrokes. If you're successful at that, so for every key the user would hit, you would just record this somewhere. For example, in HTML5 document storage, or even try to send it out somewhere. So you could also inject a keyword using this keyword event listener, for example. You add an event listener for every keystroke the user enters. In the worst case, an attacker can send all the keystrokes to his own server, and in the worst case, this might include some passwords, credit card numbers, and so on. This, by the way, happens very often. It's very easy to inject such a keylogger and exfiltrate data. So this is also a thing besides cookies, what attackers are very interested in. And of course, as always, there is phishing. An attacker can insert a fake login form into the page that manipulates the document object model, that sets the form's action attribute. So the target of this form would be the attacker server, and then the attacker would trick the user into submitting sensitive information to his server. So in other words, make a post request to the attacker server. And well, to visualize this even further, why does this work, or how does it work? XSS workflow always has three actors. So on the one hand, of course, we have the website that's vulnerable somehow. We have an attacker who tries to inject something, and we have the victim's browser where this malicious JavaScript is actually executed. So what happens first is that the attacker injects a payload into the website, for example, in a database or so, basically posts it, that do a post request to a website, the website probably remembers what the user just sent, stores this in a database, and remembers some form of malicious JavaScript. The victim will then request the website from the web page from a website. In step 3, the website serves the victim's browser the page with the attacker's payload as part of the HTML body. So in other words, the script the attacker previously sent to the server, the red thingy here, will suddenly be rendered in the victim's browser. So the victim's browser will execute the malicious script inside the HTML body. It happens in the same origin. And in this case, for example, in this very specific example, it would just send the victim's cookie to the attacker server. So window location is a JavaScript function that just replaces the current website, the current origin, with another one, and it would do so by also appending the cookie here. So the attacker now simply needs to extract the victim's cookie when the HTTP request arrives to the server, and well, after that, it can just impersonate the cookie and pretend to be the user. So the attacker has no direct relation when injecting this to the. It's not. Please do not misunderstand this in a way that the attacker does not directly attack the victim. The attacker injects something into the website of the server. Eventually, the server remembers this, then serves the malicious JavaScript to the user, and only then, for example, this is cookie stealing here. Likewise, the attacker could inject a keylogger here and so on. So a keylogger in JavaScript is just 5 lines of code. That's very, very simple and very easy for an attacker to craft. And well, as I just said here, in this case, in this example, the website would remember what the attacker injected, and this is commonly known as stored or persistent cross-site scripting. So the attacker manages to store a payload in the target database or the target file or whatever, which remains there. And usually you can remember this like a comment field, a block of forum posts, and we have many blocks, systems, content management systems. So in case whatever a user, an attacker sends there is not filtered or not well enough filtered, then it will just persist on that target. And every victim then who calls this target website will just be served this payload. Well, and the other thing is there are 2 further options: reflected and DOM-based XSS. So, for example, in reflected cross-site scripting, it's the payload, the malicious payload, is not stored in the database, but it's actually part of the request URI. So, for example, you see it in an example anyway, but it's reflected back in your response. So, in other words, you're getting a link, for example. One of the parameters includes a JavaScript, and this JavaScript is then rendered in the user's browser. And this might again include some payload. But what's different here between reflected and stored is that the malicious payload is not actually stored in the server. The server is not really involved here because it all gets rendered in. That was the third way. In the DOM-based way, the server is not involved in any way. Reflected means the server takes the parameter and then renders it on the website. But yeah, before it brings more confusion, let's have a look at this in more examples. And I really invite you to try this out yourself. What I've linked here in these yellow boxes are links to demo applets from Google. They feature demos for demonstrations for all these attacks. You can try it yourself to get a better feeling and a better understanding what's the difference between these attack scenarios. So usually, this is also, by the way, an exam question, usually and most likely in your final exam in January as well, there will be a question about XSS, and you should be familiar with these 3 types. So stored XSS, you can of course remember this by the name also. The web server stores and echoes back a payload. So for example, you have some chat stream or so. I don't know, let's take Discord, okay? Discord features Markdown. You can insert Markdown code in Discord when you write a chat message. Imagine that Discord would not filter JavaScript. Honestly, I haven't tried it. Try it out. I'm pretty sure they did a good job here, but try it out. In case they did not do that, it might be possible that you inject, for example, a JavaScript or an HTML tag holding a JavaScript, like this, some invalid image here, and on error, since X is no valid resource, I'd inject, for example, on error, this alert box should be triggered. So if I write this in the form field and say share the status, it will be stored on the web server. The web server in this chat stream, like in our case Discord, would just remember the messages forever. So whenever then this, you see here where it says you on the right part, here this code is one by one included in the HTML response, and the browser tries to interpret this. So it tries to load an image from X, which is of course no valid resource, so it will fail and on error trigger my alert box. And apparently right in this case, my session ID was this 1234.1234. Of course, an attacker could inject any other code, like the window location thingy you've seen here, could also be a payload that's injected, or a keylogger or whatever. And for any other user who would call this page, he would be shown the very same payload because it's stored on the server. So if a forum, for example, or a guestbook or a chat server or so is vulnerable to that, then this would be executed for all the users visiting. Second option, reflected cross-site scripting. The web server replies just the user input without filtering it. So filtering is commonly known as escaping it. I think you know this from our courses. So you have to escape, or where escaping means making dangerous tags harmless by rewriting them. So if this would happen, for example, if there is, for example, a form input like this one here, like just imagine this very much reminds of the Google search input. You'd enter a JavaScript here, and eventually if you click on the search button, then your search query is given to a server and appended as a get parameter here, like this request. If very often, a lot of websites have search functionality, right? You enter your query in a search box, and if you enter a script tag and the server does not filter it, and then says it will again show you the search results you were sure the search term you were searching for. If it will not filter what you just entered, it will also render the JavaScript. In that case, again in my case, it would say it will alert this. Nobody probably would click on such a link, but what if I'd hide such a request within such a URL? One you might actually click. So what if I'd, for instance, I know about, let's say, a cross-site scripting vulnerability in a website, I don't know, probably Instagram or TikTok, and you're using, or Tinder, and you're clicking on such a short link because someone sends it to you. It might look harmless like this one. You click it, and if this is exactly such a vulnerability on the website, I as an attacker, I could just steal your cookie of the website, impersonate you, know who you are, be logged in as you. So this is what makes such a vulnerability so dangerous, because you eventually manage to cloak or hide that URL. In the third way, the server is not involved at all. This is also something that happens quite frequently, especially for their JavaScript plugins, jQuery plugins, for example, offering you an image gallery where you can just, for example, go back and forth between different images. So like in this example, which you see here, there are 3 different images on this website, and I just by clicking on image 1, image 2, image 3, I could switch between them. And by doing so, the URL would just update here, like 3123, and the DOM element, what actually is shown here, the image is shown, is actually filled by the anchor tag. So for example, if you click image 1 here, it would just refer to this demo3.1. Clicking image 2 would refer to demo3.2, and so on. So that's a way that happens very often. I've seen this on countless pages doing this. And this, what happens here after this anchor tag, people think, well, this can't be dangerous in any way, right? But actually, if you implement something like this and you do it the wrong way, something like in this example could happen. So for example, you take the location string here in JavaScript, or substring 1, so this would give you 1. So name here in this example would be 1, for example. It would show image, parse int 1, HTML5, HTML, static demos, geeks, 1, JPEG. Well, no problem if this is actually 1, 2, 3. But what happens if someone injects, instead of this 1 here, would write a payload like this one here? Well, what would happen? Parse int would be some garbage, probably 0 or so, because we don't care for that. But here in this HTML tag, we would just close the tag, add our own image again, which contains this payload. And of course, the target browser would just render this. Why? Because if you set something like document inner HTML, it would just render this as a payload. So this also happens very frequently, and you have to be careful when you process these kind of parameters. And this is not a get parameter, this is after an anchor tag. So the server is not involved here at all. It just happens on the client side. So even if a website is vulnerable to exactly this, the server owner would never notice, because he won't see it in his log files. And probably intuitively you think, well, okay, then let's filter for alert or document cookie or script tag. So whenever you have a get parameter like here, make sure the user cannot enter script, or the user cannot enter document cookie. Whenever this is there, I will block it. The problem is, this does not reliably filter XSS, because in many cases, like you've seen with my attempt to load an image that doesn't exist on an error shown alert box, you can do this with a lot of tags. So there is a lot of tags you can misuse that seem legit, which you could misuse for XSS attacks, like the image tag and so on, and a lot of others. A lot of others which you could be used for that. So how can you actually prevent such kind of attacks? So by the way, if you're interested in what ways to come up with that, visit this short link here. Don't be afraid of it. It won't see any of your cookies, but you will see the varieties we have there and why you should be clever and wise when filtering. Because preventing, or actually cross-site scripting, is only a thing if the payload gets rendered in the browser. So in many cases, even if there is, for example, a website is vulnerable to cross-site scripting, the actual problem only becomes live or real if a payload can actually get rendered in the browser. Because only the injection itself is, well, it shouldn't be possible, but the harm is only done if an attacker manages to steal something. So whatever user can enter, even if it's any parameter, either get, post, or after this anchor tag, has to be filtered. Or as we know, filtering in this case is also known as escaping. So for example, in case the user enters a search query, and just, by the way, try this. Enter this query here in Google, or any other, a search functionality at some website you know, it should get, either a website will tell you the query is invalid at all, or it would get escaped to something like this. So if a query would get escaped to HTML tags, it would still show with its tags, but it wouldn't get executed. The problem is, that in practice it's often hard to consider every input. So even if you filter, for example, for these HTML tags, it might be that someone finds a way to concatenate different tags and bypass your filtering. So this is why I'd really recommend you, if you develop such an application, to use some mechanism, some very elaborate templating system or framework that already helps you in doing this. So for example, if you're using Spring Boot, if you develop a Java application, then there is an extension, I'd say, a plugin that allows you to filter for that input, and you don't really have to care for the specific filtering of certain tags. It will just help you to filter out such potentially malicious HTML tags or script tags. And also if you develop, for instance, this PHP is the most commonly used language in web applications. Make sure to do not come up with your own filters, because chances are very high that you miss something or that you overlook a possibility. And the overview you get when checking out this website is just an insight. People have become very creative on how to bypass these filters. Of course, to raise the bar of successful attacks, make sure to always use the HTTP only flag. It does not prevent that it does not fix a cross-site scripting vulnerability, but it blocks that someone can actually trade your cookie, because it will just prevent that the JavaScript which is injected can effectively access it. And out of just, if you're curious, but out of even if to see your web application from another perspective, you should use a tool like Bird Proxy, which has plugins that simulate such an attack, which can try for attack vectors so that you can figure out cross-site scripting more easily than by just looking at it. There are also other tools and websites that explain cross-site scripting very well. So so please really try out the example so that you get an understanding. As I already said, this also occurs in exams that I ask you about the difference between DOM-based and reflected, for example, and you should be aware of that. So usually people mix it up on what is injected. They think, okay, yeah, both are injected by the URL somehow, yes, but in some case the server is involved. In this case, the server is not involved at all. So get more familiar with this by trying it out. And luckily, we have very good learning resources. We have games where you can try the whole thing from an attacker perspective. And as already said, cross-site scripting happens very often. This is not something in some scenarios. So if you go to ExploitDB, for example, you will see, I've just looked up for cross-site here, okay? So you see, there's a whole cross-site scripting, persistent cross-site scripting, store cross-site scripting on the 7th of December. So yeah, let's have a look at it. What does it do exactly? Go to the Project admin panel, change the admin username, put this payload, and it will be triggered. So probably the impact is not so high here. No idea. In some cases, you need an admin username. Oh, anytime the user will visit a website, the XSS triggers. Okay, this is bad. But probably the application is not so widely used. Unfortunately, this also affects very frequently used websites. So if you browse it through, you see, for example, here a WordPress plugin, and sometimes there are also plugins which are very frequently used, some forums and so on. So from the timeline, you see this happens very frequently. And I think even, yeah, if you just somewhere if I'm looking without the minus here, you find even more. So Jenkins is a very popular tool for testing your applications. Apparently it also suffers from that, for such an attack. And again, you can see here, people have become very creative in figuring out payloads. So I'm pretty sure those who developed Jenkins, they are aware of that attack and they try to filter, but still apparently you're able to bypass this filtering at some point. So if you're curious, just look it through on ExploitDB and try to look for applications you're using. So vBulletin, for example, is a very popular forum. OpenCart is a very... Okay, this brings us to the second thingy here. Cross-site request forgery. This is a very popular shopping system which apparently also suffers from a vulnerability. But that vulnerability is called cross-site request forgery. Cross-site request forgery is not cross-site scripting. The idea of AccessRF is that there is an action that's triggered in your browser, but you're not aware of it. You did not do it intentionally or on purpose. So, for example, an authenticated user performed a sensitive action, but it didn't verify that the website, for example, did the action, the target did not verify that the user himself was doing that. So, like, intentionally. In other words, you injected, for example, something in the website, and this is then done on behalf of that user. And if such an action is possible, this is known as AccessRF. What can happen, for example, an attacker speculates, and a website does not check that, like the Facebook click checking. This is a very good example. You click on a video, this was a thing I think 2 years ago or so. You clicked on a link in order to see a video. The video was just an image overlay. You didn't really realize that it was an image, but while clicking that, it provided you were actually doing some request and posting something on your website on the Facebook newsfeed, and you were not aware of that. So, for example, some URL or some form is injected into a website, the user calls, and then it's done on behalf of the user. For example, the idea is not to steal cookies. The idea is to let a victim execute an action on its behalf, and it doesn't know about it. For example, a victim is an admin at some blog service, and it's authenticated. So usually when you run a WordPress blog, you will be authenticated as an admin because you want to change things. So let's say one of these WordPress plugins suffers from a vulnerability, then it can be that an attacker manages to inject such a payload here, like a cross-site scripting payload, okay? The website is vulnerable, the attacker injects this, but instead of stealing the cookie, the payload actually intends to trigger the admin or any user who sees this to some action the user is not aware of. So for example, this is like create a new user with that username and password, if that's possible. And if the admin user would see this and execute it, it would happen, because it would happen when the cookie of the admin would be sent to the server, the action would be executed on the victim's behalf. So in this case, XSS is just a helper to inject something. But it can also be, for example, your user is authenticated at some crypto coin websites like coin mining Moneros, and there's an online wallet, web wallet called mymonero.com. The attacker sends you a link. You click on it, or it's embedded in a website you call, and while you're still logged in there, the action would be just executed on your behalf. And this happens very frequently, by the way. A lot of people have lost bitcoins because, I've just taken Monero here as an example because it came in very handy, but a lot of people have used web wallets for bitcoins, forgot to log off. The web platforms were insecure as well. So people lost money by that, since an attacker just lured them on a website and triggered them to transfer money to them. In practice, also, there are many requests to local host resources or routers, for example, that change the admin passwords of a router and so on, that add an admin account and so on. So you have a lot of options here. To give you a real world example, for example, Hoarder was a very popular web mailer, and it also suffered from such a vulnerability. So, for example, Hoarder had a file called cmd shell PHP. I know this is stupid to include a page, to feature admins with a shell in PHP, but still. So there was a shell that was accessible for admins, and while a regular user probably would have a regular web user, mail user would have no access to that. But if there was a vulnerability and I could, as an attacker, trigger the admin into executing commands for me, then, for example, if I'd inject something like this here, and this would be rendered in the browser of the user, then I could perform this on behalf of the user. And by the way, just a few years ago, the Teach Center of TU Graz had a lot of these kind of vulnerabilities, and even with web shells, you could call compilers from inside the Teach Center and so on. But okay, this is just an example. And since we've seen it, let's have a look at another very recent example, like the OpenCard example from just a few days ago. So how does it work? Apparently, there's exactly this kind of vulnerability. So if an attacker manages to inject this thingy here, and the shop runs on localhost, so as an attacker you would probably replace this with the real URL, you could apparently trigger some checkout here, you could apparently buy some product in a fairly huge quantity. So what could also happen, let's say you go to a website and it includes such a request to your router, and probably your router is located at this IP address. And most home routers, most custom routers are always at a very, foreseeable IP address. Most are on 1.1.10.0.0.138 and so on. So in this case, there was just apparently a router vulnerable to cross-site request forgery. If an attacker included this in a website, it would be triggered in the victim's browser. If the victim actually had this router, such a request was made, and in this case, for example, the guest Wi-Fi would be activated. Yeah, you could see, okay, I don't care for that, but depending on what devices you have in a network, the impact of that could be severe. This could be some IP cameras you turn off, for example, or some even more severe things with which you interfere. So depending on the severity of the system, these attacks can be quite sophisticated. And you can see again here, all these attacks, cross-site scripting, cross-site request forgery, they happen very frequently. This is not something that happens only to minor, unimportant platforms. This happens to WordPress plugins that are used by thousands of websites that get vulnerable to that. So how can you prevent this? For example, by introducing tokens, so-called basically like nonces tokens, CSRF tokens, that can be used only once. So if, for example, there's a form field, like in this case the router, you just append here some hidden form field that's been issued by, so first the server, the router generates a token and expects this token to be sent in the response by the client. And if this token is not there, it would just not do the request. And this will effectively prevent XSS, because if you, for example, an attacker injects this, he wouldn't know the token, he couldn't guess it. So the attacker will not be able to place the token correctly, and the request will just not be triggered. Or a cookie to header token. So for example, the server sets something like a specific token, I named in here CSRF token, whatever you want to name it, it doesn't really matter. And with every request to the server, this is also sent. And of course, the attacker doesn't know this, and the attacker would not be able to. It could be faked, but this is typically not possible for the attacker, because it doesn't have control over the user's browser. Also, if you're looking around how to prevent this, there are also other methods promoted by some websites, like checking where the user comes from, whether he really comes from that website, or to constrain the allowed HTTP method to post only, but this is not reliable. So please be careful about that. Probably the token here is the best way to fix such kind of vulnerabilities. And a lot of platforms do not have this. So if you're curious about whether go to a website where you can post something, Xgit or so, If there's a form field, I don't know, you can make issues or so. Inspect the HTML source code and see if there's a token in there. Or also have a look at the cookies and try to figure out your session cookie and see if there is something in addition which would potentially prevent XSRF. Otherwise, there are chances the platform is vulnerable to cross-site request forgery. So these attacks here, cross-site request forgery and cross-site scripting, they happen very often, and you should be familiar with not only the types of them, but only how to prevent them. This will also be for sure part of the exam in January. A lot of information today again. I hope it was interesting for you and the examples helped you to gain a better understanding. So in next week there will be Daniel again, who will do a special Christmas program with you. In January you will see me again, and we will speak about the security of TLS, because this is basically what most users are used to, is the tiny lock icon in the browser, but it's also important to know what's going on behind the scenes here. And TLS also has some security features. If they're enabled, it's good. If they're not enabled, we might have a problem. So even if you see the lock icon in the browser, your communication is probably not always very secure. So what this means, you will hear about next time from me already in January. And on the 15th of January then, we will have more look on vulnerabilities, on how to actually attack TLS and also DNS security. So overall, after these two upcoming lectures in January, you will have a very good idea of what happens when you call a website in your browser, what's going on behind the scenes so that you get an encrypted communication, and how a website can actually probably inject a keylogger and so on. So that will give you the full picture. I hope you enjoyed it. I very much invite you to try out the demos that I have linked here in the slides. It will help you to get more familiar with the attack types. And of course, in case there are any questions coming up, feel free to write me in Discord or an email simply, and I'll happily answer them. So since we won't see each other again before the new year, Merry Christmas and wish you a secure 2021. Bye bye until January.